Hello friends, welcome to engineering tutorial. So we'll continue our discussion with Karnaugh map, and in the previous videos we discussed basic concepts related to Karnaugh map 2, 3 and 4 variable, and also about the mapping of Boolean expression, SOP Boolean expression into Karnaugh map. So in this video we are going to understand some basics related to grouping of cells and identifying common variables from groups, the groups formed. This. So the first step was identifying the type of Boolean expression, whether it is SOP or POS, and determining the number of variables. So from that we can determine what type of Karnaugh map is suitable for it, whether SOP or POS Karnaugh map, and after that 2, 3 or 4 variable Karnaugh map. Second step was mapping the Boolean expression onto the K map, that is, for each Boolean term present in the given expression we have to mark the respective cell as 1 or 0, well, depending on whether we are performing SOP or POS simplification. Then this is the third and fourth step. Third and fourth step. Third step is grouping, fourth step is identifying the common variables. So grouping of cells. So grouping of cell, it is done and there are certain possible ways in which groups are formed. So in order to make you understand that, let us draw the 2 and 3 and 4 variable K map, and then we will see how groups are formed. This is, let's say, a 3 variable K map. 0 1 0 0 0 1 1 1 1 0. This is A bar, this is A, this is B bar, C bar, B bar, C, B C, B C bar. First we'll look for the 3 variable K map and then we'll go for 4 variable K map. So grouping of cells, let us say in this 3 variable K map we have a situation in which the cells after mapping, they look something like this. Let's say. We have the cells that are marked in this way. So here grouping will be done of adjacent cells. Now when we perform groups, the condition is that groups can accommodate one cell, one means a single cell, 2, 4, 8, 16, like that. number of cells. In each group we can have 1 cell, 2 cell, 4 cell, 8 cells, 16 cells, means adjacent cells. Okay, so we can say 2 to the power n cells in each group. When n is 0 it is 1, when n is 1 it is 2, when n is 2 it is 4, when n is 3 it is 8, when n is 4 it is 16, when n is 5 it is 32, and so on. But mostly in 3 and 4 variable K-map you will be performing these groups, okay, up to 8. 16 cell group is very rare case in 3 and 4 variable. So we will be dealing with these kind of. So here when one cell is there, only one cell grouping is done, that is a single cell grouping. When it is 2, it is called as a pair. When it is 4, it is called as a quad, and when it is 8, it is called as a octet. Okay, that is the first condition. The second condition is that you have to accommodate maximum number of cells possible in a group. A group should contain maximum number of cells that is possible, adjacent cells should be accommodated in a group. So it should be as large as possible, obeying the rules, of course. Okay, within the rules, following the rules, the group should accommodate maximum possible adjacent cells. Okay, and the third condition, which is actually very much, it is interdependent. 2 and 3, they are interdependent. Try to form or minimum number of groups as possible. Groups as possible, because when more number of cells will be accommodated in one single group, so obviously less number of groups will be formed. Okay, that is the third condition. So these two are actually interrelated. Okay, maximum cells in a possible adjacent cells following the rules in one group means this, and forming minimum number of groups as possible. And fourth condition, which we can say important point, is that no marked cell means if it is marked 1 or 0 should be left behind. Everything should be covered. Okay, the group formation should cover all the marked cells. Okay, it should cover all marked cells, whether it is 1 or 0. So these are the 4 points. First, number of cells, adjacent cells that can be accommodated in a particular group, 1, 2, 4, 8, 16, 32, 64, 128, like that, but mostly you will be dealing with 1, 2, 4, 8 groups, because we are going to discuss mostly 3 and 4 variable K-maps. Then single, quad, pair, octet, 1, 2, 4, 8. Then maximum number of adjacent cells, marked cells, should be accommodated in a group. Okay, maximum number of cells, so a group should be as large as possible. Then minimum number of groups should be formed. Make the number of groups as less as possible. So the less the number of groups, better. So 2 and 3 are interdependent, and no marked cells should be left behind. Should be all the cells should be covered, marked cells. Okay, so now let us see what are the different possibilities of formation of groups. Okay, so you can write these points also. Okay. Okay, so here we have the marked cells that are like this. Let us just imagine that we have the cells marked like this. So how groups can be formed? So here we can form two pairs. Two pairs can be formed. One is this, another one is this, like this. See, two pairs are formed. This is group 1, which is a pair, and this is group 2. Okay. Now this group is also possible, but it is not required. Means it is within the rules that we can pair these two marked cells, but it is not required. It is a redundant group. It is not required at all. Okay. Now here, if we do like this, that you say that, let me just here it was like this, 1 1 1 1, like this. So if you say that we will perform like this, the grouping will do that, will form single cell grouping like this, these two, and will form this group, then it is wrong. Why? Because as per the rules, maximum number of adjacent cells should be accommodated in a group. So here a larger group is possible, this. So why form a single cell grouping? Here also a larger group is possible using this. So why form if the marked cells can be covered using two groups, why unnecessary form three groups? Okay. So as I said, the second and third rule, they are interdependent. That is, maximum number of adjacent cells within the rules should be accommodated in one group, and minimum number of groups should be formed. Okay. So this is the proper way. This is one group, this is the other group. Okay. This grouping is not required, it is a redundant group. Okay. Now next thing is identifying the common cells. Okay. So now we have identified the two groups, that is this group and this group. So we will write the respective Boolean terms that are involved in that group, the marked cells. First one is A bar B bar C for this element, and this is A bar B C, that is for group 1. Group 1, A bar B C, A bar B bar C, A bar B C. Group 2 is A B C and A B C bar. Because it is SOP K-map, that's why we are writing it in SOP form. So identifying, this is the fourth step, that is, once we have formed the groups, identifying the common variables in the group. So here we can easily use Boolean algebra rules to find the common Boolean variables. Like see here, here A bar C is common, A bar C is common, that is A bar C into B bar plus B, and it will be A bar C, because B plus B bar is 1. A bar C, that is the common in group 1. And here AB is common, AB C C bar, so it is AB. So the minimized Boolean expression, it will be A bar C plus AP. Here there is no more common terms. Okay, so this is the minimized Boolean expression for this K-map. So this is the fourth step. So here directly you can identify, no need to do all these things, no need. You can directly identify. See, by looking at these two terms, you can see what is the common between these two. See, A bar is common in both, C is common in both. So A bar C, directly you can write A bar C. Here A is common in both the Boolean terms, B is common in both the Boolean terms, so directly you can write AB. Directly write the answer A bar C plus AB. If you don't want to do all these things also, when you practice more and more questions, just by looking at this K-map after the group has been formed, you will get to know just by looking at the K-map. See this group 1, A bar, B bar C, A bar, B C. So just by looking you see A bar is common naturally in both these Boolean terms because the horizontal component is constant, A bar. Now the vertical component is concerned, then in these two marked cells C is common, C is common. A bar is common as the horizontal component, it is common in both the cells, so naturally A bar will be there. In the vertical component section, the cells B bar C and BC, we have only C common. Okay, here A bar is common, here C is common. So directly A bar C, you can also write in that way, you can also do in that way. But I recommend you first, when you practice first 3 or 4 or 5 questions, go the conventional way, write the groups, do the Boolean simplification and find the common term. Then when you get acquainted with that step, then without doing the Boolean simplification, just by marking the common terms, you find the common variables. Then after doing that for 5-6 questions, then you go for identifying the common terms directly, because if you go directly this way, there is chance that you will make some mistakes. So don't do that. First to go the conventional way, practice some questions with that, then find this way, and then by directly looking at the Karnaugh map. Okay. So here we have another possibility. We'll explore another possibility of how to group formation of groups in a 3 variable K-map. So here let us say we have this situation where the cells are marked accordingly. So here how we can form groups. So we know that there are certain possibilities in which groups can be formed: single, pair, quad or octet, maximum cells in a particular group, minimum number of groups possible, no cell should be left behind. So always keep those 4 things in mind while forming groups. So here you see these 4 cells that are marked as 1, they are in one line. So here we can form a quad. Okay, we can form a quad. So that is group 1, let's say. Then these 2 cells and these 2 cells, we can also form a quad like this. Okay, this is a very interesting thing, this and this. Okay, so this is also a quad, this is a quad, and this group 2, that is also a quad. Okay, so here you don't do like this. If you do something like this, I'm just doing here, there is like this 1 1 1 1 1, it is like this. So here if you do like this, let us form a pair here, one pair here and also one pair here, then it is wrong. It is wrong, because here unnecessarily you are forming 3 pairs where the whole, the situation, the whole cell coverage can be done using 2 quads. So the 2 condition, minimum number of groups, maximum element in a particular group. So those 2 conditions have to be satisfied. So here you are unnecessarily forming one extra group, and also that group, the pair, it contains less number of cells in a particular group. Okay, so always remember, when it comes to formation of groups, the priority always like this: octet first, quad, means after that quad, then pair, then single. Okay, highest priority will be given to a larger group. And when it comes to forming number of groups, the less the number of groups, the better it is. Okay, always try to form less number of groups. Always try to figure out ways of covering the marked cells using less number of groups as possible. Okay, always try to form a bigger group which can cover all the marked cells. So this approach is wrong, this is right. Okay, so here if we try to identify the common terms, so first we'll use the conventional approach for group 1. We have, so see another important thing here, there is no need to go for the conventional approach. See, shortcut, directly by looking at the Karnaugh map you can find the common term. In this quad, this horizontal component A is constant in each cell. See, in each of these cells A is common: A B bar C bar, A B bar C, A B C, A B C bar. So naturally A is of course common. Now in each of these 4 cells, can you find any common thing, any common variable? See, here it is B bar C bar, here it is B bar C, here it is BC, here it is BC bar. So you cannot find any single common variable in these 4 cells. It is continuously changing. Here it is B bar C bar, here it is B bar C, here it is BC, here it is BC bar. So nothing is common in the vertical section, but in the horizontal component A is common in each cell. A is common in each cell, but in the vertical section there is nothing common. There is nothing common. Here it is B bar C bar, here it is B bar C. So up to this B bar is common, but here it is changing B, but C, up to CC is there, but here again it is changing, C is changing to C complement, B is there. So nothing is common in terms of B and C, only A is common. So group 1, directly we can write it as A. Okay, we can directly write it as A. Okay, now group 2. So in group 2 also, if we look at, we have to consider it is not 2 pairs, it is 1 quad. So if you try to find common variables, so here in the horizontal section there is no common thing, because here it is A complement or A bar, here it is A. So nothing is common in terms of horizontal component. But when it comes to vertical thing, here it is B bar C bar, here it is BC bar. Okay, B bar C bar. So let me make it, try to understand here. A bar A, B bar C bar, B C bar. It is like this, isn't it? 1 1 1 1. The quad is formed like this. So here in the horizontal components, the cells, there is nothing common. There is nothing common. Here it is A complement, here it is A. In the vertical components corresponding to the cell, one is B bar C bar, one is BC bar. In this B bar, B not common, C complement is common, C bar is common. So here in group 2 the common thing is C bar. Just by looking you can do it. Why unnecessarily you will write all the Boolean terms, then you will do the simplification? Unnecessarily it will take a lot of time. Okay, here directly by looking at the cell you can find out what is the common term. See, here in the first group we directly saw that in the vertical section there is nothing common, in the horizontal section there is only one common variable, which is A. Group 1 done, A. Group 2 we formed like this. In the rough you can do, see, in the horizontal section there is no common variable, here it is A complement, here it is A. In the vertical section we have C, B complement B, no common variable in terms of B, but C complement is there in both the vertical components. So C complement is the common variable. So the minimized Boolean expression here for this marked cell is F is equal to A plus C bar. Okay, that is the minimized Boolean expression. So always remember this, try to form minimum number of groups, maximum cells should be accommodated in a group, and pair, single, pair, quad, octet, maximum priority to the higher populous group, most populous group. So like that, always remember those rules. So here let us consider two 4 variable K maps which are marked in this manner, and we have to form groups. So here in the first case you see these 4 cells, they are adjacent to each other, and as a result we can form a 4 cell group, a quad here. Okay, and here these 8 cells, 1 2 3 4 5 6 7 8, they are also adjacent to each other, sidewise, topwise, like this. So here also we can form this octet, 8 cell group. Okay, another important thing which I want to tell you, that the cells should, when groups are formed, cells should be adjacent to each other like this. Okay, like this, or like this, horizontal vertical adjacency like this, or if it is like this, then there is a possibility of a quad. Then this is also a possibility. But if there are 2 cells like this, let's say this and this, like this, you cannot form a group like this, it cannot be done. Cross grouping cannot be done. But there is another possibility where, let's say we have elements like this, let's say we have elements, these kind of groupings are possible, but cross grouping is not possible. We cannot group 2 cells that are connected, which are marked, which are across each other. They should be vertically or horizontally adjacent to each other. Okay, sidewise, top, bottom, left or right, like this. Okay, so this is an important thing. Now here in this group, only one group is possible. So here in this group, if we try to find the common terms, let us do it. So 1 1 1 1. So we'll write the horizontal and vertical components. Here it is A bar B, AB, and here it is C bar D, CD. I'm just writing here in rough so in order to make you understand, but when you practice these things more and more, you can just by directly looking at this, you can find the common term. So here, if we compare the horizontal components, this, what is common in these two horizontal components? B. B is common. Okay, so B is one common element, variable. When you compare the vertical components C bar D and CD, what is common? D is common. So BD is common in this group. That is the common thing, BD. So here this simplified Boolean expression for this K-map is simply BD. In this K-map here directly by looking at this K-map, you can see that there is nothing common in terms of the horizontal components. See, it is changing throughout, A bar, B bar, A bar, B, A, B, A, B bar. So nothing is common. Okay, nothing is common in terms of the horizontal components of the cells. But in vertical, there is C bar D and CD. C bar D and CD. So in these two, D is common. D is common. So D here is the common variable in this group. So as there is only one group, so the simplified Boolean expression is D for this K-map. Okay. So here we have taken some other interesting cases which are I thought I should tell you. So here in this 4 variable K-map, you see the cells are marked like this, the corner cells. Okay, the corner cells. So here we can form a 4 cell quad like this. Okay, remember I told you that corner, like this, if cells are like this, then they cannot be grouped, or if they are like this, then they cannot be grouped. But here they are the corner cells, so in this case a quad is possible, grouping is possible. Okay, so it will be a quad, and if we try to find the common term, then let's write 1 1 1 1. Here it is, the horizontal and vertical components, A bar, B bar, C bar, D bar, C, D bar and A, B bar. So if we compare the horizontal and vertical components, in the horizontal we have B bar common, so B bar. In the vertical we have D bar common, so D bar. So the minimized Boolean expression for this K-map is F is equal to B bar D bar. B bar is common in the horizontal side, D bar is common in the vertical side. Another interesting thing is this here. In this we have taken this 3 variable K-map, this was a 4 variable K-map. So in this 3 variable K-map, you see all the cells are marked as 1. So we can form one big octet accommodating all the cells of the K-map. See, all the cells of the K-map. So here in this octet, you see all the cells are accommodated. So there is no common variable. Okay, no common variable is there. So here the minimized Boolean expression whatever it will be given as 1. Okay, 1, because you see everything like this, we can write it as this into 1, this into 1, or this into 1, 1 like this. So we can say that 1 is the common thing in all these cells that are part of this big octet. which is all the cells of the K-map. Okay, so this is one. So these are the two cases which I thought I should share with you. Okay, so we will be solving a lot of questions related to 3 variable K-map, 4 variable K-map. So we will see a lot of different types of group formations which will be done. So here I am just trying to make you acquainted with how groups are formed. So we discussed some examples, but we will be discussing a lot of questions related to 3 variable K-map, 4 variable K-map simplification, and there you will come across many type of group formations and how we identify the common variables. So don't worry, so we'll solve a lot of questions. Okay, so I hope you like this video related to group formation, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.